Okay, we'll look at some of the homework problems that are in section 7.4. Like in problem number 1, you're going to order from least to greatest. You have 0.9, then 0.9 repeating, 0.97 repeating, and 0.977 repeating. Okay, if we order these, let's see, 0.9, and then 0.9 repeating will be 0.999, and so on. And then 0.97 will be 0.979, and so on. And then 0.977. And it repeats. I'm going to use the same number of decimal points here. Now, of course, in the tens place, the 9 is the same. But then when we get to the hundreds place, you can see that the numbers are different. In this case here, the greatest of those numbers that are in the hundreds place would be this 9. And that's in 0.999 or 0.9 repeating. That's this number right here. That number will go first because that's the greatest. And then we need to find out what's the second greatest. We have to compare these two numbers first. And you can see here, we go to the thousands place. You can see that this number is greater than this number. 0.97 was 0.97 repeating. That goes second. And then 0.977 repeating will be third. And the last one will be 0.9. Okay, so that would be the order of those numbers from greatest to least. And in this case, it'll be answer D. All right, problem number 2. Indicate whether the statement is true or false. In this case here, you got the negative square root of 4 is an irrational number. And you want to answer that as true or false. Well, in this case here, if I take the square root of 4, that's going to give me 2. But then the negative sign on the outside will make that negative. In this case, negative 2 is a rational number. It's not irrational. So therefore, this will be false because I can convert that into a rational number. Now, there are square roots that are considered to be irrational. But in this case here, I can find the square root of 4, which is going to be 2. And then the negative sign would be negative 2, which makes that a rational number. All right, problem number 3. Find the principal square root of the following number without the use of a calculator. And that's the number 121. So here we're finding just the principal square root or the positive square root of 121. Well, I know the fact that 11 times 11 will give you 121. So here, the square root of 121 will simply be 11. All right, problem number 4 is to find 3 rational numbers between 7 and 9. And you have your choice of answers here. 3 irrational numbers here that are between 7 and 9. Well, I know the fact that 7 is the square root of 49, and 9 represents the square root of 81. Okay, so I need to find which one of these will be between the square root of 49 and the square root of 81. And they have to be irrational numbers. So here I can eliminate B and D because these are not irrational numbers. In B, we have a set of repeating decimals. That's rational number. That's a set of rational numbers. Here, I have terminating decimals here in part D. Answer D. That's rational. So it's got to be either A or C. And they got to be, and these numbers underneath the radical has to be between 49 and 81. And the only one that's between those is A. You have the square root of 61, square root of 63, square root of 68. Those numbers are between the square root of 49 and the square root of 81. So these numbers in answer A is between 7 and 9. Right, number 5, determine For what real numbers of x, if any, the following statements are true? Like in part A, the square root of x is equal to 5. Well, we can find out what number, the square root of what number would give us an answer of 5. And a good way of doing that would be doing the opposite of the square root, which will be taking a square on both sides. And when you do that, you'll find out that 5 squared will be 25. Because the square root of 25 will give you an answer of 5. All right, part B, the square root of negative x equals 5. Okay, now in this case here, if you take the square on both sides to eliminate the radical, you'll have this, negative x, because that eliminates the radical, equals positive 25. But of course here, we want to find out what x is. It has to be the opposite of 25, which is negative 25. And you can go back and do the check to see if you replace your x with negative 25, you have the opposite of negative 25, which is positive 25. And the square root of that would be 5. So negative 25 would be the solution to that particular problem. And then finally, part C, where you have the square root of x equals to negative 5. That means you want to find some value of x where you take the square root of that, that's going to give you negative 5. In this case, there is no value of x that would give you, where you can take the square root of that to get negative 5. So in this case, there is no solution. Okay, because we can't take the square root of a number and then try to come up with a negative answer for that. Okay. All right, number 6 is a set of numbers here that you're given. You want to name the irrational numbers from the list below. Okay. Here we have to look at each one of these one at a time. As you can see here, negative 4 is not irrational. This is just plain negative 4. It's an integer. 0 is not irrational, and neither is 91, because those are integers. D is not irrational because it's a terminating decimal. E would look like a candidate for an irrational number, because when you take the square root of 7 on the calculator, you're going to come up with a non-terminating, non-repeating decimal. F is not irrational because I can find out what the square root of 49 is. It's 7. Neither is 4.5 because that's a fraction, a mixed number. Also, negative 23 over 27 is not irrational because in this case here, that's in the form a over b because it's written in the form of a fraction. Now, I would be irrational because this is a pattern of non-terminating, non-repeating decimal. 29, 299, 2999992, and so on. That's not a pattern of numbers that repeat. It has to be a consistent pattern. So E and I are the only two irrational numbers. And in this case, it'll be answer B. And then finally, number 7, determine what real values of x, if any, the following statement is true. Where the square root of x is equal to 4, well, you can find what number, when you get a square root, will give you an answer of 4. So in this case, if we take the square on both sides, or square both sides of that equation, that would be just x is equal to positive 16. And you can check to see if it's reasonable. Take the square root of 16, you'll get 4. So 16 will be the solution to this radical equation. Okay, this should be enough to assist you with some of the problems that are on the MyMathLab homework.